guys, welcome to my space. It's your favorite science tutor. So in today's video we shall be looking at a new topic, trigonometry. What is trigonometry talking about? It is simply the branch of mathematics that studies triangles, basically triangles, in relation to their sides and angles. So we shall begin with a very vital aspect we call the Pythagoras Theorem. Pythagoras Theorem. Now, in Pythagoras Theorem, we basically consider a right angle. So, given a right angled triangle, right angled triangle. Right angled triangle is a triangle that is having 90 degrees attached to it. So this is a right angle triangle. We have the right angle, it is 90 degrees on this side. And let's call these A, B, and C. Now, in triangles, we normally use capital letter. Capital letters represent the angles, while small letters represent the sides. So this is A, the side that is opposite A, which is this side, becomes small a. This is angle B. Angle B, the side that is opposite B represents small b. So this is small b. And then this is angle C. The side opposite angle C represents small letter c. So like I said, the sides represent, we use small letters to represent the sides, while we use capital letters to represent the angles. Now, what is Pythagoras Theorem talking about? The longest side in a right angled triangle is called the hypotenuse. So this is known as the hypotenuse. That is the name of the longest side. We have two sides. It all depends on the angle. For instance, this is theta and this is considered to be alpha. Now, working based on theta, the side that is opposite angle theta is length BC, which is side A. Considering this side, the side that is opposite the angle alpha is this side, length CA, which is side B. So, working with respect to angle theta, the side opposite theta is A because it is opposite, so we term this side as opposite because it is opposite the angle theta. So we consider this to be opposite, and then the side that is close to angle theta, we call it the adjacent. Adjacent. So we shall be making use of theta for this course. We have the longest side, hypotenuse, the opposite, and then the adjacent. Now, how do we derive the Pythagoras Theorem? The Pythagoras Theorem simply states that the square of the two short sides equates the longest side. What does that mean? It simply means that I have length BC. So the length of BC all square plus the length of CA. The length of CA all square will equate the longest side, which is BA. So it's going to give me length A, B, all square. The length of the longest side is the square of the length of the longest side is equal to the square of the two short sides. So BC square plus CA square equals to give me AB square. Inversely, BC simply means A. So I have A square plus CA gives me B square equals to give me AB gives me C square. So alternatively, it simply means that I have been able to derive a simple algebraic equation for Pythagoras Theorem. Simple and straightforward. So inversely, if I'm to look for any of the sides, for example, I'm looking for the hypotenuse, which is the longest side, to find C, I simply square root both sides. So I'm going to get the square root of a square plus b square. That gives me the side of the hypotenuse. Simple and straightforward. And how is it applied? When we are given two sides of the triangle, we can find any of the sides. We are given the two short sides, for example, A and B, we can find the hypotenuse. If we are given the hypotenuse on one side, we can as well find the other side. So this is a simple mathematical expression to determine Pythagoras theorem. I state once again, it states that the square of the longest side is equal to the squares of the two short sides. That is Pythagoras theorem. Now let's consider trigonometric ratios. Trigonometric ratios. Many times in mathematics and in calculations, we ought to make use of the trigonometric ratios. And it begins with a triangle. So we consider a triangle. We consider a triangle. Consider the figure. Consider the figure below. We have a triangle. How do we derive the trigonometric ratios? Angle A, B, and C. This is the right angle. So we've always known this is the hypotenuse, this is small c, small b, and small a. Now, in trigonometric ratio, we have the same, we have what we call sohcahtoa. How do we derive this? This is for sine. Sine simply says opposite over hypotenuse. Cosine, adjacent over hypotenuse. Then tangent is equal to opposite over adjacent. So let's derive the trigonometric functions. We begin with sine. Considering the angle, sine theta is equal to opposite over hypotenuse. Opposite over hypotenuse. What does it mean? This is the angle, so the side opposite the angle is A, so we have opposite A all over hypotenuse, which is the longest side, A over C. That is for sine theta. Sine in full written S-I-N-E. Okay? Now, the second case we have cosine theta. Cosine theta, or for short, cos theta. It simply says adjacent over hypotenuse. Adjacent side is the side close to the angle theta, so we have B over C. B over C. We also have for tangent theta. For short, we call it tan theta. Tan theta is opposite over adjacent. Opposite over adjacent. Opposite over adjacent. That makes A over B. Now, this helps us in solving right-angled triangles. Whenever values are given, and then you want to find theta as well, you also find the angle, you will also find the sides that are involved in the right-angled triangle with the help of sohcahtoa. This is basically used for a right-angled triangle. We also have the inverse functions. For inverse functions, we shall be considering their derivatives. The first one is what we call cosecant. Cosecant theta. For short, we call it cosec. Cosec. It simply means the inverse of sine theta. So for cosecant theta or cosec theta, we use the inverse, which is 1 over sine theta. 1 over sine theta. So it's inverse. 1 over sine theta, which means 1 over sine theta is A over C, which automatically means C over A for cosecant theta, which is cosec theta. The second function we have is what we call secant. Secant theta, or for short, sec theta. For sec theta, we make use of 1 over cos theta. 1 over cos theta, that is the inverse of theta. In this case, it becomes c over b. So we have it as c over b. And then finally, we have for tangent. The word tangent is a full pronunciation, tangent, or rather, we have one we call cotangent. Cotangent theta, or for short, we call it cot theta. But theta is 1 over tan theta. And tan theta, 1 over, that is the inverse of tangent theta, which automatically becomes b over a. So we have it as b over a. This helps us in solving problems. In our next video, I shall be taking you through what we call special angles, derivation of special angles. We have the likes of 45 degrees, 30 degrees, 90 degrees, and 60 degrees. Because many times in the exam, you encounter problems that involve not using calculator or even 4-figure table. So how do you process such functions? We shall be looking at it. Thank you for watching this video. See you for next section. Have a nice time.